Hello everyone, welcome back to my YouTube channel. My name is Royal Kosaev and welcome to the next episode of Malware for Fun. Okay, so today we're going to do an interesting research. Basically, I saw this tweet from VX Underground, which they're amazing, I should say. And also don't know from where they getting this weird mumbo jumbo pictures, exorcism stuff, which I like. Not my type, but they're very nice. And yes, so they tweeted about something about that 2nd of May of 2022. Sentinel-1 released some alert about new ransomware dubbed as Yashma, which I think it's a Japanese or whatever, by the name, of course. So Yasha is basically a ransomware builder, and it's somehow attributed to the Arvin Club gang. So I don't know about attribution and threat intelligence stuff, specifically for this builder or whatever. So first of all, I want to thank VX Underground for providing such amazing resources and tools, and of course papers and malware samples. I also linked their website in my own website, Malware Analysis Co., which provides malware analysis resources and online courses. So basically, let's get into business and look for the Yashma ransomware builder. So basically, if you go and click on the link, it will like this, download it straightforward without any questions or registrations or stuff like this. Let me just delete this guy. And let me copy it to my virtual machine. I will validate that the virtual machine, of course, is not open to some network, whether it's to my physical host or to the internet for now. So let me just disable the VMNet and also the NAT here. The reason that I'm not disabling it from the Windows, like from the virtual machine guest operating system, is because there is an ability to basically for malware to execute itself on the operating system, and a malware can potentially detect that the network adapter is basically a virtual based network adapter. You can enable it potentially and try to from there to get into other assets. So if you basically disable it from the guest operating system settings themselves, like basically from going to settings, I think it will be much more harder for the malware, if not possible, to enable this network adapter. So let me just copy it to the virtual machine. Just do copy and paste. And we have here the Yashma ransomware builder. And as I always say, I approach into those videos and I make those videos without previous knowledge on this specific sample or specific tool or whatever. Of course, if I'm doing some revisiting on some variant of a different malware that I had experience with, of course, in like Keylogger, for example, or if I'm researching about a tool like PSExec or stuff like this, of course, I have an experience with it. But whenever you're learning something or doing something, it's not always like, yeah, I know how PSExec is working. Yeah, maybe you know how to operate it, how to execute the commands, how to use the arguments inside it, but you don't really know how it's working. Like, if you want to really understand or start to understand how a specific tool are working, you have basically two layers of understanding. You have from the, if I'm talking about PSExec, you can research it in the network level. You can literally spawn Wireshark and try to understand based on what protocols it executes commands, how it operates in the network. And also you can basically put it in IDA Pro, for example, and start reverse engineering the binary itself and start to understand what are the functionalities, what kind of capabilities it has, and how everything is implemented in the code level. Okay. So after saying this, let's basically unpack here this zip. A lot of people in the industry ask VX Underground, what is the password for for extracting the malware? So guys, it's infected. INFECTED, infected, lowercase, and it's always like this, or most of the times. I like to put my password of infected mushroom. This is my type of thing. So let me just extract it. Yashma ransomware builder, and of course I validate. Don't have any internet connection or connectivity to my host. And I'll do route print also. Yeah, of course I don't have anything goes to my host, whether it's through NAT or bridge or whatever. Of course, if you want any internet connectivity for some reason, you can use NAT. Still, you have some probability of getting your host infected. Not like bridged, of course. That's if it's bridged and the malware has the worm capability, it can propagate itself into other computers. So you need to be very careful in using bridged. So my recommendation is use NAT, and if you can, configure your VMnet basically to route its traffic through another virtual machine like Remnux, for example, which is a Linux distribution. It includes a lot of tools, and you can inspect from there a lot of interesting stuff regarding network connectivity of the malware, fingerprinting stuff, what type of data it tries to send, what C2 or CNC server it tries to connect to, and everything else regarding network. So let's get to this folder. So we have this Yashma ransomware builder. First of all, kind of interesting for me if it has already some detections or whatever for the builder itself. Like, let's go do hash my files, take the 256 and get it to Firestore. Firestore.com. Search, put this bad boy inside, and we already have 38 out of 69 detections. I always check who does not detect them, but it's not always true, and not always telling you specifically, because sometimes those engines are partially integrated into Verisol, so don't take it literally. If it's, for example, Sentinel-1, it says it's undetected, but and for me hard to believe that they don't detect it. Or for example, Chronis. Okay, so, and as you can see, also they use static engine or static machine learning, whatever. So maybe their dynamic engine is not implemented inside. So again, whenever you see some vendor not detecting, don't go and say, hey, they don't detect me, so yeah, it's it's cool, whatever. So you need to check it literally with an agent, implemented, deployed on your virtual machine, and run this thing. Okay, so let's check for details. We have here E32, of course, and it's so it literally has the name of Yashma inside the descriptions. What else? Okay, So I don't see that it's packed in some way, because again, it's basically it's just the builder. So I don't think it's need to have something fancy inside. So basically this is the detections. Let's go and actually execute this bad boy, see how it looks. Okay, so this is the Yashma blah blah builder. So don't worry, you can return all your files. All your files like document blah blah blah, we don't encrypted, what guaranteed. Okay. 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 So, like this is the builder of the ransomware executable itself. It's not like the malware which literally does everything. It's the builder itself. Now we can go and analyze and research how the builder works, how it builds stuff. But I don't think it's interesting for me right now. So as we can see, it has the capability. It's like it says that it has the capability of randomize file extension. So I can put another extension maybe, or just randomize it, whatever. So like a lot of ransomware has their extension, for example, I don't know, that sparrow, that blah blah, that whatever. So they encrypt the file and put an extension on it. So they will be attributed in some way, and their victims know how to approach them. Of course, in order to approach them, in order for the victims to approach those attackers, they'll put a README file. Okay, so we have this, and spread local drive surprise. What the hell? So I can put here whether it's C drive, D drive, whatever. That's what I think. And the process name, or the file that will be built or generated whenever we do build, I think it will be svc host exe. It's a legitimate looking executable file. So if we go to task manager, we have like go from all users in any type of Windows, basically 7, 10. We have SVC host, which are basically a host process for services in your computer. So it's kind of easier for attacker to blend in inside inside your computer whenever they execute it. So if I go here to file extensions, I think it's like literally the file extensions that the attacker will configure, to target. So whenever this built or generated ransomware sample will be executed on the targeted victim, it will go for those extensions or to the files with those extensions and basically encrypt them. So if I want, I can include another extensions like .txt or whatever, for example. But of course, I will not do it here. Don't need to. And we have decryptor and options. So change desktop wallpaper. Okay, so let's play a little bit with it. Download some funny wallpaper. Oh shit, here we go again. CJ style. I just mute my phone. Okay, doing this freestyle. So, oh shit, we go again. Always like this meme, kind of funny. So, let's do save image to download. And copy it to the desktop just to play with it. And select image, desktop, and this template, blah, blah. Okay. Decryptor name, save. Okay. So I think you created public key, so don't delete, blah, 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 blah. Okay. So this is the decryptor. Okay. So yeah. So it says that it uses AES and RSA, not something in surprise. We can configure delay for some reason. Maybe it's good for some reason to bypass EDRs, or I don't know. Maybe I want to like wait to be less suspicious or whatever, for you know, for the one who actually is fallen victim into executing this file is like, okay, he's executed something, nothing happens, and then after, I don't know, after 2 hours, it's like, oh, it's encrypted. So it doesn't realize that it's because maybe it's because the double click it did for the execution of this file. Okay, add to startup. It's basically persistence mechanism. Thanks, and select icon. And we can select the same. Yeah, it literally search for ICO. Maybe we can just change it. Maybe we need to provide something smaller. But I don't try to teach you how to build malware. It's nothing like this, like a generator tool that generates, you know. Okay. Ryuk ransomware. Okay, so yeah, it's somehow correlated to them. Unhandled exception. Okay. Continue. So let's just build it and put it into downloads, or Yashma builder in the desktop, and call it Bolabla. But never used, blah, blah, blah. Okay, maybe it's because the icon. Oh, doesn't work. Oh shit, okay. So let's close it again, open. Try to build it as is, without wallpapers, without nothing. Build. Name field is empty, okay. Okay, let me just build it. Okay. So I think it's because I like literally put the wallpaper or the icon or whatever. It basically broke the building process. So now I have this blah blah ransomware, supposedly. So let me just close this guy. Now let me just do it like this. Let's take the hash MD5 maybe this time, and put it again on virus total. Okay, so of course we will not have anything related to it, because supposedly it generates something different each time it's built. Okay, maybe it has some, random function or whatever. So of course we don't have something to relate to, so let's try to maybe upload it to VirtualTotal and then to integer and try to kind of understand how it looks like. So let me just do it from inside. From inside the virtual machine. So VirtualTotal.com. Of course, I don't have an internet. You just quick enable it. Yeah, now I enable it, so we can now upload it. Confirm upload. And let's see the detections of this file and the attributions also. And let's try also to use integer analyze. I hate when the virtual machine works this slow. Amazing. So now we'll upload file. Going to desktop, Yashma Ransomware Builder, and the blah blah exe. Let's learn new stuff about this malware. For now, not a robot. Funny guys. Okay, so okay, so Acronis by its static machine learning, whatever engine, flags it as suspicious, or literally the name of their like signature is suspicious. I don't know, because by VirtualTotal, if it's suspicious, I think it's actually colored in yellow, whatever. We have ransom. So yeah, HydroCrypt, Eldorado, FileCryptor. Like, try to understand what attribution has, and if they actually detected as Yashma or Ryuk or whatever behaves like Trojan. Okay, so it's like 36 out of 68, kind of like the builder itself. So maybe the builder and the built ransomware file has something in common, like very much in common. Okay, try to see if there is high entropies or whatever relations related to some other files. Okay, so from behavioral standpoint, okay, so it's actually like executed it inside the parcel sandbox, and of course it dropped some files like the readme itself, or basically. Okay, so interesting. Pros3, like Explorer, execute blah blah, SVC host, which is the actual like unpacked or executed malware. And yeah, interesting. Let's see if integer something for us. So of course it'll take some time, but here we go. So chaos ransomware. Okay, so chaos, Ryuk, Yashma, all this stuff. So we have here let's check the related samples. Okay, seems like it took a lot of code, or maybe it's the same family or the same group. Again, not something that I go into too much, attributions and groups and stuff like this. So he checks for capabilities. So it seems it has very like has the email test too. So yeah, it's like a yeah, it's a testing builder that somehow I don't know got into the public. I don't know how X Underground got them, but of course, again, thank them for the sharing. We can learn a lot from those malware and from the builders itself. Um, so let's go like deeper into the sample, I think. Yeah. So if I go and open it inside detect it easy, let's start with detect it easy. See whether it's packed or obfuscated or whatever. Go to Yashma, blah blah exe, and we see it's a .NET compiled. Okay, so it's a .NET malware, and from the entropy standpoint, you can see it's not packed at all. So if I go and open it inside the NSpy, I can read the code. So I open it inside the NSpy. So basically, let's go and start sending. What do we have here? So console application, drive notification, program. Okay, here we go. We have all the functions. Everything is open. Don't see anything obfuscated. Interesting. Okay, so let's start like from scratch. Drive notification. Okay, so it has some classes defined. Stat parent of whatever it does gets a handle. Stat parent of what? Stat parent directory maybe, or child and new parent process. Something with import of user 32 DLL. Maybe it's for the extraction of the, we have this, we saw in virus total, we have basically the explorer exe executing the code like the blah blah exe, and then it basically executes another child process, svc host exe, which is basically the same name, like the default name of the malware sample generated by the builder. Here we go, we have we have the config here, as we can see, of the file extension it goes to. Okay, so I think it's actually the configuration of the malware, all of the variables it needs and stuff like this. Okay, so let's get back. So it said the parent at clipboard format listener, maybe grab some, clipboard stuff if you copy stuff or he logs them. So at clipboard listener, interesting. Okay, maybe we have such function explained anywhere in Google. MSDN. Place the given window in the system intent clipboard format listener list. Panel the window. Okay. So malware, the magic number, the magic word, not the magic number. It's not MZ or something. Okay, so plug monitoring clipboard. So hexacorn again. It's like, I think it's the second video I stumble upon his blogs. It's amazing. Okay, what else? So many sandbox tricks. So let's prevent this 3 ways check load content is changed or rely on dedicated APIs. Okay. There's 2 ways to incorporate these functions. Anti-sandbox. It's actually used for anti-sandbox. Okay, interesting. Checks for virtual machines or whatever. Okay, we'll try, of course, also executing it inside our own virtual machine. What else we have about it? What is Python malware? To open. I have a fiber optics internet cable, so I don't think it's a problem from my side, but whatever. So let's just continue. We'll check if it does something fancy. Goes and search for some regex pattern. So pattern match, searches for some pattern inside whatever at the current clipboard. Okay, so it actually incorporates this thing just to like check. Okay, so goes into the current clipboard, gets the text. If the drive notification, if it starts with BC1 for some reason, it has mutex, replaces it, set the text, whatever it is. Okay. Whatever. Get text, blah, blah, blah. Okay, so yeah, let's see drive notification. What drive notification? Try to get sense of it. You know, whatever. Okay, see if it actually tries to take something from the clipboard, or maybe even try to do anti-sandbox like written in the blog of Hexacorn. So let's continue with other stuff. So we have here when they import everything, like so drive notification form starts with blah blah blah. We already saw it. So this drive notification class, for some reason, that's so interesting, I think, but we'll check it elsewhere. So let's see what do we have here. We have the program and an open note. So folder path, takes the folder path, and this is the dropping of the readme, basically, like so we don't need to check this. So it adds links to startup, gets the folder. You know, they try basically to say to you, go to this URL for this Bitcoin URL, whatever, pay us. Here we have the AES encrypt. And basically takes a file and takes the file one by one in some sort, of course, it will be in some sort of for loop, and encrypt it one by one. So yeah, file dot something. So this is for the extension itself. So after it is encrypted, it takes the path, the input file, puts the dot, and then random string extension. So this is basically the same thing we saw in the builder itself. Whenever a file is encrypted, it gets a randomized file extension. So this is the function basically. Not something fancy. Yeah. So let's continue. Encrypt large, maybe for large files. Yeah. So again, same stuff already running. It checks if it's already running. Gets the process of the computer. Remote machine, get process info. So it gets the process info, the PID of each of the process, like function, calling a function, calling a method. You can call it a method, a function, whatever you want. Gets the current process. Then basically takes the location of the executing assembly, the PID, and if it's so if process file name assembly get executed assembly location takes the location with the current process ID of this whatever not equals to the process with this ID. It expects to be whatever. It's kind of weird because PIDs in Windows, of course, are randomly assigned in each execution. So, okay, whatever. So if this is true, it will return true. And else it will do an exception and maybe exit it, basically. Like checking a mutex, basically, in malware. Okay, so we have base 64 encoded string to base 64 whatever string. Take the byte, get byte, plain text, convert. See, maybe AES uses it also. Base 64. What kind of plain text they taking? Like, what they try to do? Whatever. Maybe they just took functions from other malware and implement them without really using them. So check directories for its string value. Okay, so it checks for those user and user that, which is basically the one of the registry keys loaded into the registry when the computer is loaded. For some reason, it checks for those files also. So if directory contains value for each value in array, false. Okay. So who actually calls this function? If I go analyze, used by encrypt directory, used by encrypt directory, look for directories, main. Okay. Like this is the main function. Okay. This is the start. This is the start of everything basically. So I try to go like one by one here, but from here we go like from main, like we do in normal case of malware analysis. Run. Okay, so run command. Got to run command. Set wallpaper. This is the wallpaper. Blah blah blah. Okay, so set backup services. It always fascinates me about backups in ransomware. Backup service. So they will check for all those backups. Beam, GXSS, blah blah blah. Team viewer. even. So for maybe remote administrator not able to remotely manage it. Kind of interesting. PDF service. The hell they want to disable a PDF service? Whatever. Sophos backup or Sophos antivirus. I think Sophos backup. Maybe Sophos says also a backup service or whatever. Pronis agent. So I'll go to again to main. Let's go to main forbidden countries. So goes start to check if we have something with forbidden countries like. So we have AZ Latin America. Like it's a Latin America. AZ Lat. I think it's Latin America, whatever. Latin Azerbaijan. Which code? Azeri. I think it's language codes. Azerbaijan. I have to make sure. AZ Latin Azerbaijan. So they don't want to like target Azerbaijan and these guys Turkish. Okay, Azerbaijan and Turkish. So let's check again. So for each string, being array, try string name, input language, blah blah blah, culture name. So forbidden country. So basically, if one of those country is inside, it will show message box, literally a message box with forbidden country. So if you want for your network or organization to not be infected, you can go and configure your computers as one of those locales. Of course, I don't say you need to do it, but it's kind of funny. So if program registry value, it will check for, okay, so basically software object get value up mutex. It's like, okay, so I think it will try to search for this mutex. Yeah, up mutex run. So it's basically mutex for him to see whether it's executed already or not. So if program registry value, new thread delegate, okay, so it will run the program and start it. So basically, see here, run. And start. Okay, so it will do program.run. So again, it's like application run. This is one of the things I don't like about analyzing .NET based binaries is the fact that it's like millions of methods calling each other. You don't always know when to stop. Run message loop, activate, blah blah blah. Okay, so yeah. So it's like I think a basic .NET stuff used here, whatever. So program, if program is over, get path and try to delete the file. So maybe it will basically delete itself, or after the SVC host exit, it will delete it, will execute it. It will delete this blah blah exit that I've generated. Whatever, already running. So it checks whether it's running or not. Flip out temp folder, copy resist for admin, which is this option we saw in the builder. Read all bots, write all bots exist. Okay. What is this friendly name? I'll try to resist. So if we go here, with local drives. Resist for admin privileges. Delete all volume. Delete the backup catalog. So basically it will do this. All of those. Okay, so I think I didn't enable them. So yeah, I'll go here. I will not see the functions. Run as cross windows. Okay. So we'll try to do some deletions, disable stuff. Startup, this is the persistency. Yeah, the persistence, of course. Run key. So it will be called supposedly update task. So if we go to this one, after we execute this ransomware, we will see this, supposedly need to see this resistance. Delete backup catalog, disable recovery mode, will literally execute this bc edit set blah 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 command. And here is the VSS admin, delete shadow copy blah blah blah, wadmin for deleting the backups. And here is an example how you can learn from a malware specific techniques, whether it's for evasion or disabling stuff, or if you're a red teamer and you want to simulate specific actions or specific, I don't know, adversary or an APT group. A lot of times it's great to like literally research their malware and write your own version, or literally use their malware but try to reconfigure it or patch it for your own needs, of course with OPSEC in mind and without breaking the client's network. So we need to be very careful. You need to know what are you doing. But one of the examples, disable task manager, like literally disable task manager. I could not do task manager. Okay, we'll check all of this. Stop backup services. All those backup services we already saw. Look for directories. We'll go for those directories. Take literally the drives you have, like C drive, E drive, all those. Directories, and it will start encrypting the directory. How it encrypts it? Take the files inside, get the extension, get the file name, change the extension to lower, change the extension, create passwords, whatever. Okay, so yeah, I think maybe this is the building of the encryption key or whatever they call it. Create password, check directory content, they'll take the text. Okay, so the create password inside the text, then they taking the length of the file. So it takes the file info, each element of the file info loop. Okay, so it take just not, it's not a for loop, but will take each one of the file elements, takes the key RSA, silent the text, it will do RSA encrypt and encrypt it with the text. So yeah, this is like the function which actually, the method which actually creates the password or the encryption key. So randomly generate a key. I think append one of those, basically a lookup table for a string building, and then to go AES encrypt. So yeah, of course it's AES AES encryption key, and then we saw RSA, and of course it will base 64 everything. Not something special you see in ransomware. Yeah. So the look for directory is actually the you know the encryption, or yeah, this is the encryption method. All of the encryption occurs here, and it will do all of the other mumbo jumbo stuff. Then do spread it. I was trying to spread chocolate on the bread. Spread, get drives, get password, copy, get execute. Wherever, add an open note. So now it will open the note, one of them, whatever. One of the note it dropped. And set wallpaper. Doesn't really think. So yeah, it's what it does. Executes, checks if runs, as a persistence in the run key registry, delete shadow copy, disable recovery mode, deletes backup, everything regular in ransomware. The lookup for directories is actually the decryption mechanism. Everything like the folders, look through the folders in your computer. Everything's encrypted with a password generated or its encryption key, randomly based on a lookup table, then goes with AES and then RSA and base64, of course. Regular. For me, it's regular, maybe for others not, but nothing special goes here. And also, it's not obfuscated, not packed or something special. Don't see here process injection or something like this. Maybe you have something, but I don't see anything special. So the last thing left, I think, it's to execute it. So let me just build another version with this image, and we'll get back. Okay, now I built this blah 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 ransomware sample with the shit, we go again, wallpaper. So let's execute it. Double click. Also disable this one for the sake of security. And we'll wait, see if it works. Nothing special, just build it with the same configurations as I did before and with the wallpaper of CJ. Let's see if we have something weird going on somewhere. Okay, let's start Process Explorer. Ah, here you go. Amen. You have files waiting to burn in the disk. Whatever. Where is the... Ah, shit. Here we go again. Okay. So it's, I think, it's like terminated itself already. Like it don't have any reason to work. It's like SVC host. Need to be whatever it is, one of those SVC hosts, which is like for the ransomware perspective, it's great. Blends in. I don't know if I'll try to like start task manager. Yeah, it will give me. I thought it disables the task manager. Maybe maybe because I just executed as a regular user and not as an administrator, whatever. But yeah, so encrypted some files. Yay, ransomware. And this is the file, and here is CJ. Ah, shit, we go again. So this was for today, guys. Thank you for being with me. It was a while for me. Didn't upload video, I think, for 3 weeks. Kind of hard for me to, getting along, work and business and making videos and everything. But yeah, it's a great fun for me, and I hope you enjoyed this video and my previous videos. So if you like this or the other videos, please do like, subscribe, and see you in the next one. Take care.